Hey there, space enthusiasts! Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap in, hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. While our cosmological model rests on observations, theories, and the reassuring embrace of mathematics, there's a whisper of mystery lingering in the cosmos. Enter the cosmic drama known as the crisis in cosmology. Picture this. Different methods for dating the universe throw us varying answers, leaving cosmologists scratching their heads in collective bewilderment. Now let's zoom through a quick recap. Picture the universe as a cosmic dance floor, with galaxies twirling away from us in a never-ending waltz. One method, using the cosmic microwave background as our guide, suggests one rate of expansion. Meanwhile, another method, involving the luminosity of distant supernovas, paints a different picture. Enter the Hubble constant, the star of our cosmic show, which holds the key to this celestial puzzle. Yet, the plot thickens as these methods clash, giving rise to what we've affectionately dubbed the Hubble tension. And thus, my friends, we find ourselves in the throes of a cosmic crisis, where even the stars themselves seem to be whispering secrets we've yet to decipher. But hey, there's more to the story. Hold on to your hats, because there's a new problem in town, and it's like that annoying cousin who always shows up uninvited. Imagine this. I've spent my whole life coming up with ideas about how the universe works, only for those ideas to get shaken up like a snow globe. But here's the cool part, I'm not worried. Why? Because asking questions is how we figure things out in science. Now look up at the sky, assuming you're not stuck in a city with too many lights, and what do you see? A bunch of stars, right? And if you squint, you might spot the Andromeda galaxy, kind of like a blurry smudge among the stars. But here's the tricky bit. How much of all that space stuff is out there? Like, how much stuff is floating around in space? It seems like a simple question, but the answer is way more complicated. Enter the S8 tension, our new cosmic puzzle. It's like trying to put together a giant jigsaw puzzle, but the pieces are scattered all over space. Scientists are trying to figure out how all this stuff in space clumps together and forms galaxies and stuff. It's a big mystery, but we're on the case. Alright, let's dive deeper into this cosmic conundrum. Strap in, because we're about to embark on a journey through the intricacies of measuring the universe. Imagine you're trying to figure out the size of a room, but you've got two different rulers, and they're giving you totally different answers. That's kind of what's happening here. One way we're trying to measure the universe is by using something called gravitational lensing. It's a bit like how a magnifying glass bends light, but on a cosmic scale. Big things in space, like black holes and galaxies, can act like these giant cosmic magnifiers, bending light from faraway objects and helping us see them better. But then we've got this other method where we're looking at ancient light from the early days of the universe, known as the cosmic microwave background. It's like a snapshot of the universe's baby pictures. Now you'd think these two methods would give us the same answer, right? Wrong. The numbers we're getting just don't match up, and that's causing a real head-scratcher for scientists. This discrepancy, my friends, is what we call the S8 tension, and it's at the heart of our cosmic puzzle. So what's the next move? Well, when in doubt, fire up the supercomputers. Scientists at Durham University in the UK unleashed FLAMINGO, a supercharged behemoth of a computer, to tackle this cosmic mystery. This thing is like the Sherlock Holmes of the cosmos, crunching numbers like there's no tomorrow. We're talking over 50 million hours of computing time spread across a mind-boggling 30,000 processors. And what did FLAMINGO uncover? Well, let's just say it's opened up a whole new can of cosmic worms. This project, with its fancy name that stands for something super complicated about studying the universe, is our best shot at untangling the cosmic web of mysteries that's around us. So buckle up, fellow cosmic explorers, because we're just scratching the surface of what lies beyond the stars. The universe may be vast and full of unknowns, but with projects like FLAMINGO leading the charge, we're one step closer to unlocking its secrets. FLAMINGO stands as a paradigm shift in the realm of cosmic simulations, transcending the conventional boundaries of its predecessors. While its grand scale and impressive visual fidelity may catch the eye, its true innovation lies in its holistic approach to cosmic modeling. Unlike its forerunners, which fixated primarily on unraveling the gravitational intricacies of dark matter, FLAMINGO delves into uncharted depths by meticulously tracking not only the elusive dark matter but also its often overlooked counterpart, baryonic matter. Now, one might instinctively relegate baryonic matter to the sidelines, considering its relatively minuscule contribution to the universe's overall mass. However, such assumptions fail to capture the profound impact that baryonic matter wields, particularly in the cosmic ballet of matter distribution. Imagine a cosmic symphony where supermassive black holes and cataclysmic stellar events choreograph the movements of galaxies, sculpting the cosmic landscape in their wake. FLAMINGO, with its comprehensive tracking approach, recognizes the pivotal role played by both dark matter and baryonic matter in shaping the cosmic narrative. Yet, despite its commendable efforts, FLAMINGO encounters formidable obstacles on its quest to unravel the mysteries of the cosmos. While it excels in certain domains, such as accurately depicting the intricate dance of galaxy formation, including the captivating ballet of the Milky Way and the majestic sweep of Andromeda, it finds itself grappling with the perplexing phenomenon of cosmic lumpiness. This enigmatic clustering of matter poses a tantalizing conundrum, one that challenges the very foundations of our understanding. Indeed, FLAMINGO's findings offer a sobering realization. The comforting certainties of our established standard model of cosmology may be ripe for reevaluation. Its revelations hint at underlying discrepancies, urging us to embark on a journey of intellectual exploration and scientific renaissance. It beckons us to peer beyond the confines of convention, to embrace the uncertainty of discovery, and to chart a course toward a more nuanced understanding of the cosmos. In essence, FLAMINGO serves as a beacon of illumination in the twilight of cosmic inquiry, a catalyst for introspection, innovation, and intellectual evolution. As we stand on the precipice of cosmic discovery, let us heed its call to venture boldly into the unknown, for therein lies the promise of enlightenment and the pursuit of truth. And if that wasn't enough, FLAMINGO also butted heads with the James Webb Space Telescope and other cosmic snopes. You see, while our current theory does a bang-up job of explaining how galaxies grew up, it kinda misses the mark when it comes to how close they're huddling together. According to FLAMINGO, they're not as cozy as we thought, about 5% too clumpy to be exact. So what's the takeaway from all this cosmic drama? Well, it's clear that the universe still has a few tricks up its sleeve, and it's up to us cosmic detectives to crack the case. FLAMINGO may have raised more questions than answers, but hey, that's just part of the fun of exploring the cosmos, right? You might have a different take on this, but I'm pretty stoked about the implications for science. It's like we've hit a milestone and realized there's a whole new path to explore. Our understanding of the universe is due for some serious updates, and that's just par for the course in the world of science. I sense a big shift on the horizon, and it's got me buzzing with excitement. What's your take on it? Share your thoughts in the comments below, and be sure to subscribe to Spaceverse to stay in the loop. It's your space, after all.